right, thank you very much for coming to this talk. I know that's the last one. You're all probably tired. So I hope it won't be super technical, super hard, and very nicely flowing. And also I'm glad to be here because I feel that this is the warmest room in the entire building. So it's super cozy, super warm, so I'm glad to be here. So I'll be talking about building cloud data infrastructure with Ruby, and a few words about myself. Yes, I love Ruby. So I've been in the Ruby community for a while, built some projects, open source projects, wrote some blog post articles about concurrency, talked about data tracking at Ruby Rogues podcast. And also, fun fact, I worked at a company most recently called AngelList. They're the sponsor of this conference where I helped to basically separate them from AngelList talent that is now called Well-Found. A few other facts about myself. For example, I love sports. I love swimming. Anyone is planning to go to swim to Alcatraz on Friday? No? Okay. Me too, because I'm more like an indoor pool guy. So hats off to those brave people, because I saw one person today, this morning, literally swimming outside. So that's crazy. I also love playing pickleball with my family, but I'm from Canada. We don't have enough indoor space, so usually pickleball looks like that. And I also love martial arts, Muay Thai, but I'm concerned about my health and safety first. That is why I'm the only one who always wears a headgear, and I usually look like this. But back to Ruby and my love to Ruby. There are different types of software development. And because we're all here and we love Ruby, we'll think that obviously Ruby is a great fit for web and API development, and of course for all other types of programming and software development as well. But we need to be more pragmatic. So in real world, for example, when you're building a mobile app, you would probably choose something like Kotlin and Swift. For desktop, you'll probably choose Electron or JavaScript or something like that, C++ for Unreal Engine, and any other things. And is there José Valim here? No, too bad, because I made this slide for him because he would probably tell that Elixir is great for web and API development, but also Elixir has some projects like Broadway, NX, Nerves, and many other things. But there is also another type of programming and software development, which is not listed here. And it is scripting and automation. So hot take number one, Ruby is the best programming language for scripting and automation. And I can prove it to you. So if we go back to history and see how Mats, what he was thinking when creating Ruby, he basically thought about an easy-to-use scripting language. I also went to, AI is everywhere nowadays. I went to all these big LLM models and asked them, is Ruby the programming language for scripting? And for example, ChatGPT said yes. Gemini said yes. Claude hallucinated a little bit. It was like, no, maybe it's not the language. But I'm a software engineer, but also I'm a prompt engineer. And with a little bit of prompting, I made it say yes. So you see, this is the programming language for scripting and automation. So a little bit about what I'm building right now. So I build a company called Bemi AI, which is kind of like helps other companies build agents for customer support, primarily dealing with text and SMS modalities. Under the hood, the way it works, the platform connects to different data sources, and then we provide a Postgres compatible, I'll just throw lots of buzzwords, bottomless storage for AI agents. So bottomless storage, what it means, it's basically stored on S3, so it can scale almost infinitely. And let's have a closer look at how, for example, our platform works, and I'll describe how we use Ruby. So in our specific case, we provision infrastructure per customer, so it's multi-tenant infrastructure, and there are a few pieces that are here I'll go through. And the main idea is that we need to provide an isolation for each customer. We cannot mix and match different pieces, and it's all provisioned with Ruby. And here is how it works. So a little bit of engineering 101. We won't have time to go very deep there, but I'll just throw a few ideas so you could potentially become familiar with some of those. So one idea is the way we connect to different data sources, for example, to Postgres as a database, we connect to logical replication log. So this mechanism allows to get all data changes from the database itself and propagate and store them, etc. We connect through Notion API, for example, and different APIs to other services, or in some cases, webhooks. At the bottom, we store everything in a format which is very popular in the data engineering world called Parquet file. So think of it as a CSV on steroids. It has information about different types. It also stores information in a columnar format. So when you query or aggregate data across, I don't know, 6 zillion of rows, it can do it much quicker. It also can be compressed, etc. What else? Everything, and Parquet files are immutable. To stitch all of them together, people usually use additional metadata, for example, JSON files, etc., to point, hey, like the latest version of this row is stored in this file, so go and take a look there. And finally, there is another buzzword, kind of like technology called DuckDB. DuckDB, think of it as a SQLite for analytics. So DuckDB is a single process, kind of like database. It basically operates on the file system. And DuckDB is something similar, but for analytics. And just quickly, just on that, like the data engineering doesn't stop. Usually people then would need to bring something like Kafka or NATS or something like that. Then at some point you would need to run a JVM because it's Java and there are lots of data tools out there. Then you would need to maybe implement data streaming. Then you would start thinking about orchestrating all these workflows, then thinking about table compaction, snapshotting, and then thinking about different formats, table formats, and versions, vectors, because they are now popular for AI. Then thinking about like data quality and data catalogs, and then weird acronyms like ETL, ELT, reverse ETL, and blah, 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 all these things. So the main point of this slide is to tell you that data engineering stacks are like much more complex and much more expensive than software engineering stacks. So if you're paying, I don't know, for a database, let's say $500, it's very easy to pay thousands just to have these data infrastructure set up. So when we think about the data infrastructure and automation, people usually think about tools like these ones, for example, Ansible or Chef, Terraform or Pulumi for provisioning infrastructure as code, Docker, Kubernetes, all these things. But the question is how to automate the automation, and the answer is Ruby. So why Ruby? Ruby has a very rich standard library. It can work with all the data types that are usually kind of like used, for example, JSON, YAML, CSV. So out of the box, in this example, it's possible to generate some YAML files necessary for Kubernetes dynamically. Ruby has also a template rendering functionality, ERBs. And ERB can be used not only for HTML, but also for rendering any type of kind of like files. For example, in this case, it generates an SQL file that later can be executed. Ruby library has a built-in HTTP library. So you can send requests without introducing any gems or dependencies. It also has a good file manipulation kind of like library and functionality. So for example, if some of you are unlucky and have to use Windows, you can use file join functionality to have these backslash in the paths instead of forward slashes. Ruby also allows reading large files. For example, you can also operate with temp files. Temp files are created and then they are sort of garbage collected automatically when you don't need to use them anymore. Ruby has like a login library that you can customize if you need in your application or when you run scripts. And obviously, it can also run other shell commands and other processes. So for example, with system, you can get the output, run the command, get the output, and do something with it. With backtick, you can capture the output, you can also get the status, and if you need like complete control, you can use a library called open3, where you can control std_in, out, std_error, and also the thread of the process that is running. So the point is, very often Ruby is chosen because of the iteration speed, and this is an advantage because Ruby helps you move fast without tons of boilerplate. There is no like compilation step. It's easy to run, easy to read, and easy to debug. So hot take number 3, you can move fast but be more efficient. It's not about writing more code. And to visualize this change, I have this video. So what's going to happen, there are 2 swimmers, not so easy to see, but they will basically push off the wall at the same time. And the swimmer on the right will move faster by moving only their legs without moving their hands and all other stuff. The reason why this swimmer moves fast is because the position of this swimmer is streamlined and they're not moving fast, they're not spending more energy on doing unnecessary moves, etc. But obviously, they're also the best swimmer ever. Does anyone know who that is? Yes, exactly. The most decorated Olympic medalist, Michael Phelps. All right, a few patterns for running and writing Ruby scripts. A dry run pattern. So the idea is simple that instead of performing certain dangerous mutations or side effects, you can, when the script is run with a specific flag, you can just output what would happen. And that helps with previewing what's going to happen, debugging, and just troubleshooting in general. So that's one pattern that very often is being used for running scripts. Another pattern is called sidecar pattern. So the idea here is that you can run a helper functionality, for example, in the running a secure tunnel connection, establishing connection to SSH or something like that for the core process. And for example, if we are talking about Kubernetes, which is like infrastructure level thing, these kind of like containers, they share the networking parts. The reason why it's called a sidecar pattern is because of the motorcycles. So this thing on the right that is attached is called sidecar, and it's being attached to a motorcycle. So Ruby can be used as a sidecar, and this brings us to another hot take, number 4. When monolith isn't an option, it's okay and it's fine to go off Rails and use plain Ruby. So for example, with the sidecar pattern, you cannot bring the entire Rails for each process that you're running in multi-tenancy. So it makes sense to do something much more lightweight. Another pattern that people very often use for infrastructure is called GitOps. The idea is simple. When you write your code for infrastructure, write it in a declarative way and store it as a single source of truth in a Git repo. So it means that instead of humans, for example, committing code to a Git, in our case, a Ruby process that we call deployer, for example, can produce all the necessary files and artifacts and just push commits as usual. And then this process let the CI/CD continuous integration and deployment process run and get the infrastructure synchronized with the state of these files. Another thing that can be helpful at scale is gradual typing. Probably Dave Thomas, the previous speaker in the main stage, wouldn't be happy because of this example. I'm using classes, and he was like, hey, it's a data bucket, and you have to use structs. But there is a reason why, kind of like in this example, I had to use a class, because I'm using a tool called Sorbet that allows you to gradually annotate types. For example, for my attributes for project class, I'm saying that name is a string and ID is a string. So that helps a lot to scale the project. So in my IDE, I can, for example, ask and show me all places in the code when, for example, the name is being used. And if I do some math operations on the name, my IDE can highlight all these issues proactively. But my hot take for gradual typing is that it's really a mess in the Ruby community. Does anyone use gradual typing or any static typing tools? Not a lot of people. Maybe there's a reason why, because in the Ruby community, there's like the RBS system that reminds me of the C and C++ header files that are essentially kind of like Mats proposed this idea that types can be stored in a separate file from your source code in these RBS files. There is different like tooling, Steep, Sorbet, RBI files, and some are supported by the community, some are built in the Ruby, et cetera, et cetera. So it's a mess. All right. So there are a few best practices that can be used when building infrastructure with Ruby and making kind of like the deployment workflows work. So first, limit the number of dependencies. So when you run the sidecar pattern, for example, you don't need to bring like tons of gems, Rails necessarily. You can just use Ruby in most of the cases just fine. Reduce the number of global mutable state. Obviously, when you run scripts, it's very easy to run a script that would mutate something and you don't know what happened. So the fewer places there are where the state is mutated, the better. Make scripts idempotent, meaning that make sure when the script is rerun, it doesn't, basically it ends up in the same state as it was ran just once. So allow running the same script over and over again without breaking stuff. Mask sensitive data before login, obvious things. Validate and sanitize user inputs. So for example, when you render a template with ERB, make sure that you don't render some malicious code that users could pass. And Dave Thomas would probably support it, like do not repeat yourself when you need to optimize your code, making it kind of like more maintainable, but do it without creating needless abstractions. There are also more advanced techniques that we won't have time to cover today, but some of them are useful, especially when you're dealing with these distributed systems. For example, explicitly handling timeouts, that's helpful because sometimes your processes can run for hours and you don't know what's happening. Feature flags, they help, for example, when you need to test certain functionality, but you can test it only on certain kind of like instances instead of rolling it out at once. You can, with the feature flag, control who get to use what functionality. Rate limits are helpful, so if you're hitting some APIs or something like that, try to make sure that your system doesn't bring everything down at once. For that, you can also use retries with exponential backoff. Exponential backoff means that when you try it and something didn't work, you can try again, but after waiting for some time. And this time always consistently like increases exponentially. So that makes the system more robust. Circuit breaker pattern is kind of like the idea. If something is broken, just don't hit it over and over again. Don't make the situation worse. Just give it some time, and after the service or a system is up, then you can try again. And chaos engineering, it's like was sort of introduced by Netflix. The idea is you can simulate when some parts of your systems are down, and you can see what's going to happen. Will it end up in a mess that you will never be able to resolve or not? So that's a useful technique. So the key takeaway is simple, like Ruby is more than web. We all know Ruby on Rails. This is the framework that Ruby is famous for. But Ruby was designed for scripting, and it has applications beyond just web development. It can be used for provisioning cloud infrastructure, as I described in these slides and presentation, but it can also be used for scripting and automating many other things. So that's it for me. This is my email. This is my handle everywhere on GitHub, X, whatever. And feel free to come and say hi if you are interested to discuss some of these topics: Ruby, AI, data engineering, startups, pivots, founder stories, swimming, pickleball, martial arts. Yeah, thank you.